Thanks for joining me in this lesson where I'm going to talk about declaring and sending commands. When it comes to declaring and sending commands, and we look at our CRS, DDD, and event sourcing diagram, we reside in the top left portion of the diagram, where we're going outside of our client, the UI, creating the command and sending it, and going back with a result. Knowing this, it's best to first have a feel for what the definition of a command is, just to reiterate. The command is an expression of intent to trigger an action in the domain. So really the desire to do an operation. It doesn't state it has happened, it's stating you want something to happen, like you want to do a write in your application. When it comes to a command in Java, we could have an example like the schedule flight command here. We'll be using the flight sample domain throughout our course, by the way. With a schedule flight command, well, best practice is to make this an immutable class. We don't want our messages to be changed in transit, so make all your fields final. Only provide getters and do the regular things like an equals and a hash code and a toString in there. There's one specific excellent thing on this message you would create, and that's the @target_aggregate_identifier annotation. It is this annotation which marks the field which should be used to load the exact aggregate instance which should be handling this command. So really the field which defines which model should be used to make the decision based on this message going through. There are two other things we should note when we're talking about declaring commands. Firstly, instead of a target aggregate identifier, we can use the @routing key annotation. You would use this annotation in a distributed environment when you don't necessarily know whether the command is going for an aggregate. However, you still want to consistently route such a message. This is a hard requirement when using those commands. And this is the way to mark the field used for consistently routing your commands in a distributed environment. Also, Kotlin is a solution you could use when you're making such an application. The benefit of Kotlin is that you have a very nice and short annotation. You would almost automatically get our immutable objects out of the box by making them data classes and making the fields false so that they are final. This is a very nice approach as it allows you to combine all your commands belonging to a specific group into a single file, and it's pretty clear what they are doing because it's all combined. Having had an idea of how we're going to declare our commands and how we create them, we need to have a look at how we're going to dispatch our commands. Firstly, we're going to do this from the CommandBus perspective. The first step is to retrieve the CommandBus. We can do this from the configuration on the CommandBus method. This would give you the primary CommandBus, which is defined inside your application. With the CommandBus, when we're dispatching a message on it, we first need to wrap the command we have created in a command message. For this, you can use the generic command message as command message method, which gives you a command message wrapping your command, so that the framework knows, aha, this is a command which I'm going to send over. Then we can look at two approaches, how we're going to dispatch. We can do a dispatch and forget, simply dispatching it. We cannot really deal with the result because we're not reacting to it. If you want to react, which we do recommend, you would provide a command callback, which is a functional interface, as you see. There are a couple of implementations of the CommandBus we can use, which you could configure on your configurer, which are, for example, the simple CommandBus, the asynchronous CommandBus, the disruptor CommandBus, and the Axon server CommandBus. Knowing this, we can dive a little bit in how we would get our command result when we're using the CommandBus. So here we have a fleshed out solution of using the dispatch method and having our command callback in place. You see that this has a message and a result. The message defines the actual message which was sent, and the result is the result message containing what the solution was. It's on the result where you can check whether it was exceptional, so that you can react in exceptional situations. If it's not marked as exceptional, you should regard it as a successful command execution. This allows us to do an if-else approach, checking what we want to do. To get a feel what the command callback looks like, here is the functional interface, having just a single method on result, giving you the original command message and the command result message, carrying the result of command handling. There is also a convenience approach, providing a friendlier API when you want to send messages over through the command bus. This is called the command gateway. It's essentially a gateway towards your command bus, making your life a little bit easier. Again, we can look at the configuration to retrieve the configured command gateway from it. With the command gateway in hand, we this time only have to create our command, the schedule flight command. We can simply send this message on the command gateway. There are several approaches to using the command gateway. We have a send operation, returning us a completable future, essentially a non-blocking solution here. We can also do send and wait, which allows us to do an infinite blocking solution, giving us the result of command handling. We can also do this in a timed fashion, giving, for example, 500 milliseconds for the command to succeed. And lastly, we could go back to the command callback we use for the command bus as well, if you so desire. The result handling, when we're dealing with the command gateway, is slightly different. If you're doing the send, you'll get a completable future, so that you're, asynchronous in this process. On the completable future, we can do things like then run and then apply, which would be invoked if command handling was successful. If an exception was thrown, that would be the means to use exceptionally on a completable future to react in exceptional situations. If you're using the send and wait, you would simply wrap this in a try-catch so that the exception which is thrown from your command handler is catched on the position where you're dispatching your command on the command gateway. We recommend typically to use the completable future solution, embracing the fact that you are going to be asynchronous when you're using such a messaging paradigm. Let's have a look at the types of command results really. When it's successful, we expect no result in most scenarios. No result means we are happy, we ingested the command, your application is going to deal with it, you'll see eventually what has come of it. There are a couple of outliers where you actually return a result on the command result message. These are the identifiers of the entities you create, like the aggregate entirety in its entirety, or the entities inside your aggregate, for example. The unhappy path would be an exception, which is either wrapped in your command result message or thrown. And that's really all there is to it.